Part 284C3K26. This is another wow video. Line 22f1fa19c3k26. Higgs boson unstable isotope cross-reference Wow Seti data. So this is a cross-referencing video where I look at other videos and see what how they go together. Okay, so there's the alien radio signal. And October 23rd was when I was starting to work on this research. Today's November 19th, 2012 when I'm filming it. So I'm going to Google Higgs unstable isotope. My thoughts. I did a Google search and a bunch of videos from the Wow, Higgs, and Mu2e videos came up. So I'll put them here for cross-referencing purposes. So you guys can look at each of the videos and then look at what kind of cross-referencing needs to be done, okay? So line 22f1fa19c3k16. Higgs MSW unstable isotope formulas Foldy-Wouthuysen 5G Wow Seti, and that's this video here. I'll probably post the links when I do the video, okay? Line 22f1fa19c3k15 Higgs filled boson unstable isotope Foldy-Wouthuysen Fermions Wow Seti. That one went on the Adiago says. 2 plasma accelerator QSPA Higgs particle quasi-steady-state fusion Atlas Wow lines 10A and 18A. Higgs Wow fusion graphite plasma lines 18A 3Z 2A and 3D. Data keyword formulas. The Higgs Wow lines 18A 3Z 2A 3S4. Plasma Wick rotation Minkowski space quantum field formulas. My thoughts. Now I look at some blog posts from other writers. Quote from to Palazzo on November 14, 2011. The Marx generator will produce Engels waves, which should allow the inherently unstable isotope of selenium to undergo rapid stellination in mere trickleseconds. And that's www.bay12forums.com. Quote from Roger Arm's blog. The Higgs field does not slow down photons, therefore it does not bestow them with any mass. Particles which interact strongly with the Higgs field are slowed down the most and granted the most mass, whilst those that interact weakly are lighter. The top quark interacts most strongly with Higgs particles and is the heaviest known particle, about as heavy as an atom of gold. The Z plus and Z minus particles of the weak force also interact very strongly with the Higgs particle, but they are bosons. The Higgs field is self-referral. It slows down itself down, awarding itself with a great deal of mass, much more than that of a top quark. A massive particle traveling at very high energy through the Higgs field can create a real Higgs particle, which will then decay with a particular signature. The Higgs particle is unique and like no other particle. Only photons and gluons do not interact with the Higgs particle, both bosons themselves. Quote, a possible mode of decay for the Higgs particle, if it exists, is to decay it either into a pair of Z particles, Z plus and Z minus, or a pair of the charges W and W, all being carriers of the weak force. These two would then in turn decay very shortly afterwards into possible top quarks, gluons, and other heavy particles, which themselves subsequently decay into two jets of more ordinary particles. So that's from www.rogerarm.freeuk.com. Pages Higgs HTM. So October 23rd, my thoughts. Here I learn what needs to happen in order for us to find a Higgs particle with mass. And you want it to decay into a pair of Z particles, Z plus or Z minus, or a pair of charges, W and W plus carriers of the weak force. So you needed to create two weak force particles. So I'll need to see if you have in any of your experiments in the next video. Thanks for watching, and I'm going to start filming the next one soon.